Solids in contact with natural waters. Natural waters interact with rocks and sediments containing ionic solids having limited solubilities, thereby acquiring solutes which may be transported to other locations where they can be removed by chemical precipitation or uptake by organisms. The hard parts of marine organisms consist largely of solids such as calcite and silica, which are formed and destroyed in accordance with the same equilibria. These play an important role in determining the composition of ocean water. The solubility profiles of the compounds of CD, Hg, and Pb are of interest as they affect the deposition and movement of these toxic pollutants in the environment. Nucleation and growth. Contrary to what you may have been taught, precipitates do not form when the ion concentration product reaches the solubility product of an ionic solid. To form a precipitate from homogeneous solution, a certain degree of supersaturation is required. Smaller crystals are more soluble because they contain a larger number of edges and corners per unit of mass. Ions in these locations are less tightly bound to the rest of the solid. In any ionic solution, small clumps of oppositely charged ions are continually forming by ordinary collisional process. The smallest of these aggregates possess a higher free energy than the isolated solvated ions, and they rapidly dissociate. Occasionally, however, one of these protocrystallites reaches a critical size whose stability allows it to remain intact long enough to serve as a surface onto which the deposition of additional ions can lead to still greater stability. At this point, the process passes from the nucleation to the growth stage. Organic complexes in natural waters. There is always a certain amount of dissolved organic matter in natural waters. The quantity varies greatly up to 10 mg per liter in productive lakes and estuaries, about a tenth of this amount in seawater. Interstitial waters and sediments derived from organic rich materials may contain up to 100 mg of carbon per liter. Among the organic substances found in most waters that are known to form complexes or chelates with metal ions are amino acids, amino sugars, fatty acids, organic phosphates, phosphorins, and polysaccharides. In addition to these naturally occurring compounds, substances such as nitriurotriacetic acid, NTA, a commonly used substitute for phosphate in household detergents, are frequently present in waters affected by pollution. Clay minerals. Clays are the end product of the weathering of the rocks. They can be thought of as the skeletons of the rock material following leaching of the more soluble Na+, Ca2+, Mg2+, and CO2. Three components of the aluminosilicate rock substance, the formation of kaolin, for example, is summarized by the unique structural feature of all clays is their organization into stacks of sheet-like structures. The simplest of these sheets consists of condensed hexagonal rings of SiO4 tetrahedra. These sheets, each sheet can be regarded as a layer of silicon atoms sandwiched between two layers of oxygen atoms. O sheets are made up of similar atoms are aluminum or magnesium. In this case, the metal ion and octahedral liquid.